Riding the cosmic waves, spaceships and our quest for the stars. Spaceships are our vessels to the cosmos. They represent humanity's ambition to explore the universe beyond Earth. These incredible machines carry our instruments, our dreams, and our unquenchable thirst for knowledge. They are the embodiment of our scientific curiosity and engineering prowess. Through spaceships, we venture into the unknown, seeking answers to fundamental questions about our place in the vast cosmic tapestry. Since the dawn of humanity, we have gazed at the stars with wonder and awe. For millennia, the cosmos remained out of reach, a realm of myth and speculation. But the dream of reaching for the stars persisted, fueled by our innate desire to explore. With the advent of the scientific revolution and technological advancements, what was once a distant dream began to transform into a tangible reality. Spaceships, in their many forms, have become our eyes and ears in the universe. They allow us to study distant planets, stars, and galaxies. They help us understand the history of our solar system and the origins of the universe itself. But their significance extends beyond scientific discovery. Spaceships represent our collective spirit of adventure, our drive to push the boundaries of human ingenuity, and our relentless pursuit of the unknown. Ancient dreams, modern rockets, from mythological chariots to scientific blueprints. The journey of human imagination and ambition has been a long and fascinating one, stretching from the earliest myths to the cutting-edge technology of today. The concept of spaceships, or vehicles capable of traveling beyond Earth, has captivated the human imagination for centuries. From the earliest days of human civilization, we have looked up at the stars and wondered what it would be like to travel among them. Long before the first rocket pierced the bounds of gravity, stories of celestial chariots and mythical beings soaring through the heavens filled our myths and legends. These stories were not just flights of fancy, they were expressions of a deep-seated human desire to explore the unknown. These tales, passed down through generations, reflected our ancestors' yearning to explore the celestial tapestry that adorned their night skies. Around campfires and in ancient texts, these stories kept the dream of space travel alive, even when it seemed impossible. In ancient Hindu mythology, the Vimana, often depicted as a flying palace or chariot of the gods, traversed the heavens powered by mystical forces. These stories were rich with imagination, depicting advanced technologies and celestial voyages that were far beyond the capabilities of the time. Similarly, ancient Greek myths spoke of Apollo's chariot, drawn across the sky by fiery steeds. These myths were not just stories, they were a way for ancient people to make sense of the cosmos and their place within it. These stories, though rooted in fantasy, reveal a fundamental human desire, the longing to break free from Earth's gravitational embrace and journey into the cosmos. This desire has been a constant throughout human history, driving us to explore, innovate, and push the boundaries of what is possible. As we transitioned from mythology to the realm of scientific inquiry, visionaries began to conceptualize space travel in more concrete terms. The Age of Enlightenment brought with it a new way of thinking, one that sought to understand the universe through observation and experimentation. In the 17th century, Johannes Kepler, renowned for his laws of planetary motion, wrote Somnium, a fictional account of a journey to the moon. This work, though a blend of science and fantasy, was groundbreaking in its attempt to describe space travel in a scientific context. This work, though a blend of science and fantasy, helped lay the groundwork for more serious considerations of space travel. Kepler's ideas inspired future generations of scientists and dreamers, who continued to push the boundaries of what was thought possible. By the late 19th and early 20th centuries, the idea of space travel began to transition from the realm of science fiction to the realm of possibility. Visionaries like Konstantin Tsiolkovsky and Robert Goddard began to develop the theoretical and practical foundations of rocketry, turning dreams into reality. Their work paved the way for the space age, a new era of exploration that would take humanity beyond the confines of our home planet and into the vast expanse of the cosmos. Pioneers of the final frontier, Tsiolkovsky, Goddard, and von Braun. These three visionaries laid the groundwork for humanity's journey into space, each contributing uniquely to the field of astronautics and rocketry. The dream of space travel began to take concrete shape thanks to the pioneering work of a few visionary scientists and engineers. Their relentless pursuit of knowledge and innovation turned what was once science fiction into a tangible reality. Konstantin Tsiolkovsky, a Russian schoolteacher with a profound passion for space, is often hailed as the father of astronautics. His fascination with the cosmos was sparked by the works of Jules Verne and his own vivid imagination. His groundbreaking work in the late 19th and early 20th centuries laid the theoretical foundation for space travel. Tsiolkovsky's vision extended far beyond his time, imagining space stations, interplanetary travel, and even colonization of other planets. Tsiolkovsky's calculations demonstrated that reaching orbit would require a rocket propelled by the thrust generated by the expulsion of mass, a principle now known as Tsiolkovsky's rocket equation. This equation remains a cornerstone in the field of astronautics, guiding the design and development of modern rockets. While Tsiolkovsky was developing the theoretical framework for space travel, American physicist Robert Goddard was conducting practical experiments that would bring humanity closer to achieving this dream. Goddard's work was driven by his belief that rockets could reach the moon and beyond. Goddard is widely recognized as the father of modern rocketry. His innovative approach and relentless experimentation paved the way for future advancements in rocket technology. His pioneering work, often conducted in obscurity, focused on developing liquid-fueled rockets, a technology that would prove essential for reaching orbit and beyond. Goddard's experiments were initially met with skepticism, but his persistence eventually paid off. In 1926, Goddard successfully launched the world's first liquid-fueled rocket, marking a pivotal moment in the history of space exploration. This achievement demonstrated the potential of liquid propulsion and set the stage for future space missions. Another pivotal figure in the development of spaceflight was Wernher von Braun, a German aerospace engineer who played a key role in developing the V-2 rocket program in Germany during World War II. Von Braun's work on the V-2 rocket represented a significant leap in rocket technology. After the war, von Braun and his team surrendered to the United States, where they played a critical role in developing the rockets that would launch the first American satellites and astronauts into space. His expertise was instrumental in the success of the U.S. space program. Von Braun's expertise and leadership were instrumental in the United States' efforts to reach the moon during the space race. His vision and engineering prowess helped turn the dream of lunar exploration into a reality, culminating in the historic Apollo moon landings. The legacies of Tsiolkovsky, Goddard, and von Braun continue to inspire new generations of scientists and engineers. Their contributions laid the foundation for the incredible advancements in space exploration we witness today, from Mars rovers to interstellar probes. As we look to the future, the pioneering spirit of these early rocket scientists reminds us that the sky is not the limit. Their work has opened the door to the cosmos, and humanity's journey into the final frontier is just beginning. Fueling the journey, chemical rockets and beyond. The story of space exploration is one of innovation and relentless pursuit of the unknown. At the heart of this journey are the propulsion systems that have powered our spacecraft, enabling humanity to reach for the stars. To escape Earth's gravitational pull and venture into the cosmos, we need powerful and efficient propulsion systems. These systems must overcome the immense force of gravity, propelling spacecraft beyond our atmosphere and into the vast expanse of space. Chemical rockets, the workhorses of space travel since the early days of space exploration, rely on the combustion of propellants to generate thrust. This technology, developed and refined over decades, has been the backbone of our space missions. These rockets have proven incredibly powerful, launching us into orbit, sending probes to distant planets, and carrying astronauts to the moon. Their reliability and strength have made them indispensable tools in our quest to explore the universe. However, chemical rockets have limitations. Despite their power, they are not without drawbacks that have prompted the search for better alternatives. Chemical rockets require a significant amount of propellant, which adds weight and limits their range. The need for large quantities of fuel means that spacecraft must carry heavy loads, reducing the efficiency and increasing the cost of missions. Their exhaust velocity, a key factor in determining efficiency, is also relatively low. This means that while they can generate a lot of thrust, they do so at the expense of fuel efficiency, limiting the distances they can travel. While chemical rockets have been instrumental in our early forays into space, their limitations have spurred the search for alternative propulsion systems that could enable us to explore the cosmos more efficiently and venture farther than ever before. The quest for more advanced propulsion technologies is driven by the desire to overcome these inherent limitations. These limitations have led scientists and engineers to explore a variety of alternative propulsion systems that could revolutionize space travel. From ion propulsion, which uses electric fields to accelerate ions and generate thrust, to solar sails that harness the power of sunlight, the possibilities are vast and exciting. These advanced concepts, ranging from ion propulsion to solar sails and even antimatter propulsion, offer the tantalizing possibility of faster, more efficient, and more cost-effective space travel, potentially opening up new frontiers of exploration. Each of these technologies promises to extend our reach into the cosmos, making interstellar travel a more achievable goal. Each of these propulsion systems has its own set of advantages and disadvantages, and realizing their full potential requires overcoming significant technological hurdles. The journey to develop these advanced propulsion systems is ongoing, with researchers and engineers working tirelessly to turn these concepts into reality. The future of space travel depends on our ability to innovate and push the boundaries of what is possible, paving the way for humanity's next giant leap into the unknown.